Can you see now? You can hear me?
Yes.
All right. So hello everyone. My name is Lorenzo Jamone. I am a senior lecturer in robotics at the Queen Mary University of London, and I am part of several research groups in Queen Mary. You see down below the advanced robotics group, but also the cognitive science research group and intelligent sensing. And more specifically, I lead a team which is called CRISP, Cognitive Robotics and Intelligent System for the People. And what we do, our objectives are, so it's a twofold objective, which I think is really the objective of cognitive robotics, which is to create smart robots by taking inspiration from biological systems. But at the same time, by doing that, also understanding more about the human intelligence. So try to create this loop in which both objectives can be fulfilled. And within this general aim, what we focus on is what I call the intelligence of our hands. So the extraordinary ability we have to grasp and manipulate objects, to explore the environment, and even to communicate with each other using the hands. And so, for example, things we do are to use biological inspired algorithms for robotic grasping using both vision and touch. And specifically, we focus on situations that are the most unstructured we can. So we assume that we don't know anything about the objects. We don't know what the objects are, where they are, if they are soft, rigid, deformable. And we try to collect all this information either in real time using sensing or based on previous learning that we generalize to new situations. So really in the direction of what Shingo was saying, this uncertainty that we have in the environment and we would like our robots to be able to cope with. And then we test typically different algorithms in a lot of different situations with different objects in different conditions. And we use statistical methods to compare them in order to really understand why one solution is better than another, and trying to understand the basic principles that are important, for example, for grasping. And we use touch during grasp to maintain object stables, but in some situation also before grasping the object to explore object and understand more about their properties. And we use things such as Bayesian optimization, for example, to know where to explore, but we also use principles that are inspired by what we think humans do. For example, making the assumption that object might be symmetric, which is typically the case in many real-world objects. And then we do also work in manipulation. And first, manipulation is more difficult because on top of keeping the object stable in the grasp, then you want to move them within the hand. And for that, we take direct input from humans. So we use learning by demonstration. And we do it through teleoperation, like you see in this case. And the focus is then to have the robot reproducing these actions that have been demonstrated by the human, with a focus again on generalization. So the idea the goal will be that we teach one action with one object, for example, a translation, and then a robot should be able to do the same action with different object with the different dimensions or different stiffness, different texture. So we really want to try to find what is the best representation for the robot to be able to generalize to many different situations. And as I mentioned earlier, we also explore the use of hand movements in human-human interaction, of course, with a possible application then to human-robot interaction. And so these are two examples of projects we are doing. On the left is one about miscommunication. How do we move our hands when we are talking with each other and when we do not understand each other? Do our hand movements change in a specific way? Another project is about rhythm perception. How do we move our hands to better perceive a rhythm, an acoustic rhythm? For example, by tapping along a rhythm. And also, how does our perception of rhythm improves if we see someone else moving at the same rhythm? And yeah, so these are a few examples of the things we do. And I think if I have 1 more minute, I show another video related to what Shingo was asking. What are the problems in cognitive robotics? So when I teach cognitive robotics to my students in university, we discuss what cognition is. And I tell that cognition is what allows us to do the amazing things we do every day without even thinking much about them. And I show this video and I say, yes, so these things are amazing and you need a lot of training and exercise. But actually we do things that are apparently much simpler. And I think this is really what cognition is, doing things like this one. And we do not have a robot that can do something similar in a random kitchen around the world. So I think this is one of the objective and important points. And yeah, this is all for me, for now at least.
Okay, thank you very much. It is very interesting movies and a very interesting system. So that is very good topic for this discussion.